All right, so the first one is not any different than what we did yesterday and the day before with the quadratics. And so you are just, it is in factored form or intercept form. And when you want to find the x-intercepts, you just do the opposite of what's in the parentheses. Right, and then if you wanted to do the y-intercept without a calculator, you can put 0 in for the x's, and that becomes 3 times -2, which is going to be -6 for the y-intercept. But I feel like a lot of you just typed in the calculator and found it there, which is fine. All right, and so then that gives us 3 points on the graph, and we can get a semi-good graph from that. This one only changes direction one time, so it's decreasing and then it changes to increasing. That's one change in direction. And then the factors are going to have the opposite signs and numbers of the x-intercepts. So that is kind of a review from yesterday and basically what we've done all week. And then starting with number 2, it's not a quadratic, it's a polynomial. It's actually a cubic graph. So we're going to start talking about polynomial functions today. But we're going to do the same thing for the intercepts. You are just going to change the signs. This one's listed twice. You don't have to list the intercept twice. You can just list it once. And then we have our y-intercept. It changes directions twice. Now, D, I haven't filled in because I want you guys to try and remember some things from Algebra 2. And so what is different about the behavior of the graph at 2, which is here, versus -2? What's different about what happens there? Say it again. The increase. Maybe, I don't really understand. How does it touch the axis compared? This compared to this? Right, this one goes through, and this one just bounces at it. It just touches it and goes the other direction. Do you guys remember that from Algebra 2? Talking about bounces? No? That's okay. So at 2, the graph bounces. The reason why is because of this repeated factor. So whenever you have a factor that appears more than one time, something different is going to happen at the axis. It's not just going to go straight through. It's going to do a little extra something. And it's because the factor x minus 2 repeats. All right, and then we have this polynomial function. It's actually a quartic function. And so we can get our x-intercepts and y-intercepts the same way. This one does only change direction one time. And so now if we compare to what happens at 2 with what happens at -4, they still both go all the way through. But at 2 you have this little bend in the graph. And it's another reason because the factor x minus 2 repeats. So you can see that repetition two ways. It can be shown with an exponent, or you might actually see the factor 2 times or whatever. Now there is a difference between like it repeating twice and 3 times. So whenever there is an even number of factors, that's when you get this bouncing effect. And then when it's odd repeating, that's when you get the bend. Do y'all remember that? Multiplicity is not at all. Maybe some teachers didn't teach it last year. I don't know. Usually students remember hearing about it because it's kind of challenging. You can go ahead and go. Good luck. All right, so we're going to talk about polynomials for a while. And so one thing to know about polynomials is they always have positive integer powers or exponents. So what is not an integer? Do y'all know it's not an integer? Is a fraction an integer? It is not. A decimal is not an integer, so it has to be a whole, like an integer is going to be the whole number, so like 0, 1, 2, 3, 4, 5, and their opposites, the negative versions of all of them. But for polynomial functions, we only want the positive integers. So an example of a polynomial function would be like f of x equals 4x to the 5th plus 3x squared plus 2x minus 1. All those exponents are positive and they're integers. Right? The x-intercepts, just like with quadratics, are also called zeros. And they are x values that make the function equal to 0. That shouldn't be too new to you, hopefully. Alright, and then to find the y-intercept of any function in the entire world, you plug 0 in for x, and then find the y value. Right. And then what might feel new to you, maybe, is this the idea of multiplicity. And multiplicity is the number of times a factor occurs. And it tells you quite a bit about the graph. And so if we have this is just a generic factor. So you can imagine p being 3 or 5 or -2, lots of different things. And then k tells you how many times that factor is multiplied by itself. So in this generic form, p is going to be the 0. And it would have a multiplicity of k. Right. And then if k is odd, then the graph passes through at that 0. It'll go through at that 0. And then if k is even, the graph bounces at that 0. All right, and we can pass through different ways. So just like we saw on the other side, sometimes it passes through, like just straight through, and then sometimes it passes through and it does a little bend. So all that depends on the value of k, the value of the multiplicity. So if it just goes straight through, then k is 1. Right? If it bends as it goes through, then k is 3, or possibly 5, but typically we'll just say 3. And then bounces, it'll just touch it and then go back. That's when k is any even number, but typically we'll just say k is 2. Alright, so on this first example, we have f of x, and we're going to find the zeros. And we are going to tell their multiplicity. So this 5 out here in the front, is it going to give you a 0? No, you have to have an x in the factor to get a 0, but this does, x minus 1. So if x minus 1 is a factor, what is the 0? or the x-intercept? Okay, I said this for 2 days. I know. It was just one. Yes, it's just one. All right. And then the multiplicity of that 0 is going to come from the power on that factor. So the multiplicity is going to be 4. All right. The next factor gives you another 0. So write down what you think the 0 or x-intercept is from x plus 3. Make sure you change the sign so it should be -3. And what do you guys think about the multiplicity of it? Yes, good. All right, and the last 0 is going to be 2. And what is the exponent if you don't see it? 1, good. All right, so that was the first part, to give the zeros and the multiplicity. The second part says to find the degree, and we haven't talked about that this year. So the degree is going to be the largest exponent when in standard form. Now, f is not in standard form, and I personally don't want to multiply it all out. That would take forever. We'd have to multiply x minus 1 times itself 4 times. It would be a mess. It would be huge, too. So we can do that when it's in factored form. All you have to do when it's in factored form is add the multiplicities. Now, since we already wrote them down, they're right here. Or you could go back and do 4 plus 2 plus 1. But this one is going to have a degree of 7. All right, any question? Good. Now, in Algebra 2, it seems like that's a really hard thing to understand. Because I taught Algebra 2 a lot, and that was like really, really difficult for a lot of kids. But then this year, when people see it a second time, it kind of starts to make a little bit more sense. Okay, another thing we're going to do, I think, on all the rest of these is find the equation of the polynomial function. And so this little box, it tells you the steps. We have to find a. And so our first step is to write the model using the factors, or write in factored form. Okay, so on 2, I'm going to call this one f of x. And so we always are going to start with f of x equals a. And then for each 0, or x-intercept, we're going to put a factor. So this one has 3 zeros, so we're going to have 3 factors. And then we will do a factor for each 0. So for -3, that's going to be x plus 3. So make sure you use the opposite. And then -1 will be x plus 1. And 4 will be x minus 4. Now, if your graph bounced at one of those or did a wiggle, a bend, then you would also take in consideration the multiplicities, but on all of these, it just went straight through, so we don't have to worry about that. Okay, so there's that. All right, then we're going to plug in the y-intercept. That is the extra point. And we kind of did this yesterday in a smaller scale. And so the y-intercept here is the point 0, 2. So we're going to put 2 in for y, or f of x. And then we're going to put 0 in for all of our x's. So that ends up being 3 times 1 times -4. or negative 12a. Alright, and then to solve that, we will just divide by that negative 12. And then in reduced form, a is negative 1/6. Now, don't be too surprised if a is a fraction, like almost every one of these is probably going to be. Right, and then your final step for the equation is to go back to that purple one that we wrote and just put negative 1/6 in for a. And then if you wanted to, you can check that in the calculator. Let me just type it in real quick. All right, so there it is. And then we'll look at the graph. And it pretty much matches. You could double check on the table to make sure like all those points, there should be the point 0.25 on there. Oh, so I've got my calculator to do something different, but when I put in 2, I do get 5. So we're good. That is it. All right, and then number 3 is a very similar question, except instead of the graph, they just give you the information in words. But we're going to do the exact same thing. I'm going to call this one g of x. So we start off with g of x equals a. And then we're going to do a factor for each 0. I almost messed up. Make sure you do the opposite on those. And then a y-intercept of 3 means it's the point 0, 3. So 3 in for g of x. And then all those x's become 0. So I'm going to do this one a little shorter and just like, if the x is 0, you can just drop off the x. Alright, so 6a is equal to 3. Divide. A is going to be 1/2. And then just take it and plug it into that light blue one. And then on number 4, we're going to do all the things. So number 4 asks us to start off with the graph. And so we know this polynomial has a y-intercept of -5, so I'll go ahead and put a little dot at -5 on the y-axis, 0 at -1, at 2, and then at 4. And then the 0 at 2 is going to be a little bit more special than the other zeros because it has a multiplicity of 2, which means that it bounces there. So this is what our graph should do. It should only touch the x-axis at those points, at the x-intercepts. We can't have an extra cross. So it's going to go down and then back up. It's going to bounce. And then go back up. Now, there's probably some things wrong with that graph, but in general, it's a pretty good graph. Okay, that was the first thing. We're going to sketch the graph. And then it tells us to write the equation. So that's where I'm going to call this one H. We start with h of x equals a. And we're going to do a factor for each 0. Be careful because this one, this 0 has a multiplicity of 2, which means I have to do a power of 2 up there. Okay, so now, just like the previous two, we're going to put in our y-intercept. Don't forget that square on the one that has a -2. Oh, I messed up. That y-intercept is -5, not +5. That's the second thing they asked us to do. And then the third thing, they asked us to find the degree. So whenever your function is in factored form, it's right here. It's in a weird place, the information is. When it's in a factored form, remember you add the multiplicities. So what do you guys think? What would the degree be? It would be 4. So you're adding 1 plus 2 plus 1. All right, what questions do you guys have? Okay, we'll practice this on Monday.